Welcome to our day of rules of exponents. We're also going to pick up a little bit of information on scientific notation today. All of this should be pretty familiar to you. The rules of exponents, we're talking about when do you add the exponents, when do you multiply the exponents. Remember, the key factor to every one of these rules is you never change the base. You're only working with the exponents. The bases do not change. That's a key factor for doing all of these problems today, as well as when we get to working with the scientific notation problems as well. Okay, our first rule is simply our rule about what happens when you are multiplying two terms together that have the same bases. And what do you do the exponents? If you look at example number 1 here, we have x to the 8th and x to the 23rd. And hopefully you're going, well, heck, that's no big deal. I can do that. I simply add the exponents and I get x to the 31st. The y's, of course, will do the same thing. You're not changing the base. You're leaving y alone. And you'll have y to the 16th. That leaves us then to fill in our rule then that we don't change the base here and we simply have b to the m plus n power. You add the exponents. Now the ones I always see messed up are like the second example here, 5 to the 6th times 5 to the 4th. And for some reason when it's numbers we all want to go, oh, 5 times 5 is 25. But no, we never change the base and that stays 5 to the 10th. Our second rule involves what to do when we have an exponent raised to another exponent, and hopefully you're going, oh yeah, that was easy. We simply multiplied those together. So in this case, I would have 2 to the 4th. I would have k cubed to the 4th, that's k to the 12th, and y to the 20th. Nice easy thing, I simply multiply those exponents together. Same thing applies on the second example when I have a fraction. The cubed power up here has to distribute to every term. So that would include the 3. So we would get 3 cubed, f cubed, and on the bottom when we multiply that together that would be h to the 30th. Now on one like this we would probably then, since cubed power isn't that big, we would go ahead and work it out and make that 27 f cubed h to the 30th. Rule number 3 is simply what do you do when you have a 0 power, and hopefully that's an automatic. The big question, if I have something to the 0 power, is it always equal to 0 or is it always equal to 1? And the answer would be yes, anything to the 0 power is always equal to 1. And let me remind you why. If I gave you x to the 7th divided by x to the 7th, you would both go, well, hey, that cancels. And I would have a power of 0, 7 minus 7, but when it cancels, it also equals 1. So yes, anything to the 0 power is 1. And down here, I have a little bit tricky. You got to be careful with what do I do with this problem? And I'm going to ask you a second. So what's the answer to this one? Lots of 0 powers should be pretty easy. I'm guessing I either have people saying, hey, this is 1, 2, or the answer is 4. And the last one would be correct. The whole quantity is to the 0 power, so consequently the whole thing becomes 1. But over here on the right side, 3 does not have a 0 power on it. 3 does not become 1. Each of the variables becomes 1, and so therefore I'd have 1 plus 3 for a total of 4. Okay, there's our first 3 rules. Move into the next page. We have our rules about division and negative powers. Okay, well, obviously, if multiplying variables meant you add the powers, dividing means you subtract the powers. Usually the top one minus the bottom one. But we also always like to have our answers have positive power. So if I want my solution to have a positive power, then I need to always move it so I keep my exponents positive. Now this one I put an extra piece in here. I have a 36 and a 27. Those are just coefficients out front. So those, treat them like it was a simple fraction. How would you reduce 36 over 27? Well, they're both divisible by 9, so they could reduce down to 4 over 3. And we would have 4/3 then. Remember with variables, the easiest way is to always move them to be positive. But we've got to remember, well, what does a negative exponent mean in the first place? So we come over here to rule number 5, you'll notice that, oh, b to the negative n, you recall negative powers simply mean move it to the opposite side of the fraction. So this would move down and become b to the positive n power. When you have a negative power, you simply move it from top to bottom and make it a positive power. So the second example here, if I b to the negative n on the bottom, when I move it to the top, it becomes b to the positive n. And finally, this one's kind of a shortcut. If you have a fraction with a negative power on it, the negative power is going to make them switch positions. So it's actually easier to just go, oh, flip it upside down and put a positive power on it. Then I would have b to the n over a to the n. So negative powers, you just have to remember to switch from top to bottom. Now on our example though, I have a w to the first on top and a w to the negative third on the bottom. Well, since I have that w to the first, I need to move it so I always keep things positive. And rather than going through the whole set of fancy rules of exponents, these are actually much simpler if you simply go, okay, that's a negative 3. I need it to be positive. When you bring it to the top, it becomes a plus 3. And you're going to add it to the one that's already up there. I'm not sure why that didn't write very well. So when I have 1 plus 3, I would actually end up with w to the 4th power in the numerator. Okay, the x's, which one do I move? Do I move the negative 8 down or move the 7 up? Whenever you move from top to bottom, it changes signs. We want to end up with positive powers, so therefore, we're going to choose to bring the negative 8 down, which would make it become a plus 8. And if I do 7 plus 8, I really have simply an x to the 15th. So we now have x to the 15th in the denominator. Okay, the y's are both negative, so which one do I move? Well, I want to end up with a positive number. So if I bring negative 2 up and change it to positive 2, that's not going to add up to be a positive number. So you actually need to bring the negative 4 down. And if I bring negative 4 down, that will make it become a plus 4. When I take negative 2 plus 4, I get y to the 2nd. Last but not least, the z's are both positive powers. So which one should I move to keep it all positive? I know I'm going to end up subtracting them. And hopefully your answer is, well, okay, I got to move the 7 down because I could subtract 7 from 11 and keep a positive power. And so I would be left with z to the 4th. And there's your simplified solution. These other two examples I have are common mistakes. This is one of those things that makes math teachers cry. I would really, really like this to be an easy automatic, but something about working with bases that are numbers and negative exponents, we go hog wild crazy and forget all the rules. Negative exponents always mean move it from top to bottom. So if I see this problem, I'm simply going to go, oh, I have to move it down. The 4 is the base. It has to go down with it, and I get 4 to the 1st power. So in other words, 4 to the negative 1 is just 1/4. Negative 6 to the 0. Anything to the 0 power is 1. So that's just 1. And then this last one, it's a negative 2 power. So I have to drop the base to the bottom, including the negative. And now it's going to be to the positive 2 power, which is really simply another 1/4. So in the end, I have 1/4 plus 1 minus 1/4. 1/4s are going to cancel, and my answer is 1. The third example, if I have 1/5 to the negative 1 power, what does the negative power do to a fraction? Yes, boom, instantly flip it upside down. It's now 5/1, technically to the positive 1 power. You wouldn't have to write all that. The second one also flips, 3/2, now to the positive 2 power. With fractions, it's easiest to just flip them over. Now, crunch the numbers. We got 5 plus 9/4. When I make a common denominator, 5 becomes 20/4 plus 9/4, and so my answer is 29/4. I prefer answers as improper fractions. I'd rather not have mixed fractions, and at this level of math and beyond, improper fractions are our friends. We like them this way. I do want them reduced, but I don't want to change to mixed fractions. Okay, last but not least then, you have a short little handout about scientific notation. And this is more for the science people than for me, but we'll hit a little bit of this. I need to remind you, number one, how do you change something into scientific notation? And then, how do we calculate with scientific notation? So if I said turn 43 million into scientific notation, you will hopefully remember that when you go to scientific notation, the coefficient, the number in front, can only have one digit left of the decimal. So this has to move to become 4.3. I have a 4 to the left. Any other significant digits are going to be on the right. The question is, I know it's times 10 to some power. How did I figure out what power it was going to be? I simply move over 1, 2, 3, 4, 5, 6, 7 decimal places, and so I have 4.3 times 10 to the 7th. Okay, I always remember if 443 million was a number that's bigger than 1, if it's a number bigger than 1, it has a positive power. If it's a small fractional value between 0 and 1, it's a decimal, in other words, it's got a negative power. Forget that, you move left, you move right, you can't keep it straight. Depends on whether you're starting in scientific notation or you're starting with an ordinary number. Who knows which way to go. Just remember, if it's got a positive power, it's a number bigger than 1. If it's got a negative exponent, it's a fraction value between 0 and 1. You can logically do it from there. Our second example here, the 0.0001027. Well, okay, if I move it so I only have one number left of the decimal, that means the decimal is going to move to be after the 1. So we have 1.027 times, I move the decimal point 1, 2, 3, 4 places. Okay, that's a tiny little decimal number. Therefore, it has to have a negative exponent. It's times 10 to the negative 4. Okay, the big thing we do with scientific notation, particularly in chemistry and most importantly in physics. I didn't personally get good at this until I took college physics, and then wow, did I learn to do scientific notation. So you have to remember, this is nothing more than writing, if I had written 2.8 a to the negative 6 power. Its base number is 10, and I actually, sorry guys, I have that written wrong. There would not be a parenthesis there. Well, if I can get the eraser to come back, I'll fix it. There we go. That should have, and I still did it wrong. That should have been 10 to the negative 6 on the inside, parenthesis on the outside. Sorry about that. But the point is that 10 is nothing more than if you had x to the negative 6 or p to the negative 6, it's just a base. So if you were going to multiply these together and they weren't written in scientific notation, you all wouldn't think a thing about it. You would multiply those coefficients out front, you would add your exponents, and you'd be done. So that's all we need to do in scientific notation. You multiply the constant numbers out front, which will get you 16.52 in this case. And then you multiply the base 10s. 10 to the negative 6, 10 to the 19th. Rules of exponents say you should add. So negative 6 plus 19 would be 10 to the 13th. Now, the one thing you have to do after this point is you have to have it in proper scientific notation as an answer. By the way, anybody who changes every one of these back to standard numbers and does not use scientific notation to work the problem is in big trouble. You have to learn how to use scientific notation. You don't turn it back to an ordinary number and then chunk it in your calculator. Learn to do scientific notation. In this case though, my final answer is not in proper form. I need my decimal moved over 1, so I have 1.652. So if I move that decimal by 1 place, the big question is, I know I have to change the exponent by 1, but do I make it get 1 bigger or 1 smaller? Well, what I always remember is I went from 16 to 1.6. 16. And so, sorry about that. Obviously, that was my phone going off. We're almost done here. So 1.652, I made it, the number get smaller. I went from 16 to 1.6, so I'm going to make the exponent get bigger. You have to go opposite. So that's going to end up as times 10 to the 14th. So if you make the coefficient out front get smaller, you make the exponent get bigger. This last one is a twofold one. I would recommend, since it's got division and multiplication in it, multiply the bottom first. Get that combined. You don't necessarily need to put it in proper form yet. If I multiply 4.2 times 7.5, I'll get 31.5 times, then I need to add my exponents. 10 to the fourth, 10 to the negative second is 10 squared. I could move that back to proper form, but it's really not essential until I do the division. Now, with scientific notation, everything must move upward. You cannot leave anything in the denominator. That's important. So what am I going to do to the coefficient numbers in front? 2.7846 divided by 31.5. I am indeed going to divide them. And if I divide that, I'm going to get 0.0884. The exponents on the 10 have got to also have to move up. Doesn't matter whether it's going to give you a positive power or a negative power. Remember, negative powers are okay in scientific notation land. So if I bring that 10 squared up, I'm going to be subtracting 2. And so I'm going to be left with times 10 to the second. And here's where I have a problem because I'm out of board space. So that's going to give me times 10 to the second. Now, is my final answer in proper form? No, it's not. My decimals are most definitely off. So if I move that over 2 decimal places to make that 8.884, the big question is I have to move my decimal, or my exponent, by 2. Do I make it get too bigger or too smaller? Well, I went from 0.08 to 8.84. That means I made the coefficient get bigger in size. So therefore my power has to get smaller in size, and in which case then I actually am going to have to subtract 2 from my power. I have 10 to the second here, and I'm going to have to subtract 2 from it, which is actually going to leave me with a very unique answer of 10 to the 0. If you were asked to write it in scientific notation as a final answer, you'd have to leave it as 10 to the 0. But we also know that that's 1, so in standard form, the number would simply be 8.84. But if you're asked to work your problem in scientific notation, that would be your solution. Okay, hopefully all of that went well. If you've got questions, you know where to find me. Good luck.